Let's look at fractional indices. So indices are also called powers. Now a power is a number that tells another number how many times it needs to multiply by itself. For example, if you have 10 power 2, so 2 is the index or it's the power. So this one is telling us that 10 needs to multiply by itself twice. So 10 times 10, that is what it basically means, which is equals to 100. If you have, say, 5 power 3, this is telling us that 5 needs to multiply by itself 3 times. So we shall have 5 times 5 times 5, 1, 2, 3, being equals to 125. So a power can be a whole number like 2 or 3. It can also be a fraction. We could have 10 power 1 over 2. Yeah, it could be a negative number. We could have 10 power negative 2. And it could also be a combination. We could have 10 power a half minus 2. So the index can either be a fraction, negative, combination of all, positive. So it can be in very many various different forms. So the opposite of a power is what we call a root. Depending on which root is being calculated, you put a number before at the start of the root. For example, for square root, you could simply write that, or you could put the 2 in front. Then for cube root, you write it, the 3 comes in front, then the root sign. Then for fourth root, you write the 4 and then the root sign. So the opposite of a power is a root. Now let's look at how to write a root. Let's say we have root of 81. This is equals to plus or minus 9. Why? The reason is because positive 9 squared gives us 81. Also, negative 9 squared gives us also 81. So a square root of a number gives us positive and negative value. Whereas if we had a cube root, say, of 27, this gives us 3. So 3 is the only valid answer. You cannot say positive or negative 3 because it gives totally different answers if you consider a negative. So this is only positive 3. Then another thing you need to know about a square root is if you square a square root, for example, if you have root of 36, then you square it, this makes it to cancel out. So the square cancels with the square root, and therefore it just becomes 36. Now, sometimes we cannot simplify a root. In such incidences, we can leave it as it is. And if you leave it like that, that is what we called surds, or in the surd form. There are also some cases where you can simplify part of the root and then leave the other part as a surd. For example, if you have root of 49, this one, it calculates itself completely. So this is 7 squared, root of 7 squared. So this cancels with a root and we are left with 7. Whereas if you have root of 17, this cannot be simplified. So we can leave it as it is. If you have, say, root of 27, this can be simplified. 27 is the same as 3 times 9, which is equals to, this is the same as root of 3 times root of 9. And we know root of 9 is 3. So this is equals to 3 root 3. So that is what it means. Now let us look at negative powers. If a power has a minus in front of it, then that means that the base value has to be reciprocated. For example, if you have a to power negative 1, this means this base, which is a, has to be flipped down. So this will be equals to the power, it is 1 over, you reciprocate this, 1 over a, then times the power, in this case, which was 1. which is the same as 1 over just A. Let's say you have A to power -2. You have to first of all flip the base. So it will be 1 over A. Then you power the whole thing by that number that is after the negative sign. So it will be to power 2. This is what it means, which is equals to 1 squared over A squared, which is 1 over A squared. So let's say you have 1 over 5 to power -3. So this, since it has a negative before the power, that means we reciprocate the base, which is 1 over 5. So the reciprocal of 1 over 5 is 5 over 1. Then you power with that power, which is 3. So this will be equals to 5 power 3 over 1 to power 3, which is equals to 5 to power 3 is telling us to multiply 5 by itself 3 times. So it is 5 times 5 times 5 over 1 times 1 times 1, which is equals to 5 times 5 times 5 is equals to 125 over 1 times 1 times 1 is 1, which is equals to 125. Now let's look at our main topic, which is fractional powers or indices. Fractional powers or indices. Now, a fractional index is a power of a term that is a fraction. So this implies that the power or the index is a fraction. Now, for such, the way we work it out, first of all, the denominator becomes the denominator of the fraction, which is the power. The denominator of the power, which is the fraction, the denominator of that fraction, which is the power, it becomes the root of the number. Then we raise the result to the power of the numerator of that fraction. For example, if you have A to power m over n, so what this means, so this denominator, which is n, becomes the root of the number A. So this will be the nth root of A. Then m becomes the power. We raise the power, the result. So this to power m. So this is what it means. So let's say we have 8 to power 2 over 3. This simply means that, so the denominator is becomes the root of this 8. So the third root of 8, then we put the power, which is 2. This is what it implies. Okay? So this will be equals to, so the cube root of 8 is 2. So you square 2. 2 squared is the same as 2 times 2. It's telling us multiply 2 by itself twice. So 2 times 2, which is equals to 4. So that's how you deal with fractional powers or indices. So let's say you have a value like this one, 32 over 3125 to power 4 over 5. Now this is a fraction to power a fraction. So this will be, so we said the denominator becomes the root of the base. In this case, the base is 32 over this. So it will be root, the fifth root of 32 over 3125, then to power the numerator of the fraction, which is 4. So this will be equals to, this we can separate the roots, so we can have fifth root of 32 over fifth root of 3125, then to power 4, which is equals to, so the fifth root of 32 is 2, and the fifth root of 3125 is 5. Then you square. So this is the same as 2 squared over 5 squared. So 2 times 2 is, this is 4, it's 4. So this is the same as 2 times 2 times 2 times 2, 4 times. So 2 to power 4 is 16 over 5 to power 4. Multiplying 5 by itself 4 times gives us 625. So that's how you deal with fractional powers. Now, what if we have negative fractional powers? For example, if you have a question, say 4 to power negative a half, how do you deal with this? So remember, we said you first now have to deal with the negative. So the negative implies that you have to reciprocate the base. The base is 4. So the reciprocal of 4 is 1 over 4. Then you you power with the power without the negative. Then we go back to what we said about a fractional power. We said that denominator acts as the root of the base. So this will be equals to square root of 1 over 4, then to power 1. The numerator becomes the power. So this will be equals to root of 1 over root of 4, which is equals to 1 over 2. Let's look at another one. If you have 4 over 8 to power negative 1 over 3. Now what we have to do is to first deal with the negative. The negative means we reciprocate the base. 4 over 8, its reciprocal is 8 over 4. Then we power with the 1 over 3. Now this will become, so we say the denominator is the root. So this will become cube root of 8 over 4, which is the same as cube root of 8 over cube root of 4, then to power the numerator, which is 1. So this will be equals to, so the cube root of 8 is 2, then the cube root of 4, that one, it cannot be simplified, so we can leave it as cube root of 4. So that's how you deal with those fractional powers, the negative ones. Now, how do you deal with multiplying and dividing terms that have powers? For example, if you have x to power 2 times x to power 3. So this simply means you add, if you have a multiplication, what you do is you add the powers. So this will become x to power 2 plus 3, which is equals to x to power 5. Then if you have, say, x to power 8, divide by x to power 4. If you see a division, that means, and it's the same base, that means you can subtract the powers. So this will be equals to x to power 8. Please, you must make sure that the bases are the same. Here it's x, x. The powers can be different, but the bases have to be the same if you're going to use this. So x, this means x to power 8 minus 4, which is equals to x to power 4. Then what about if you have a number or a power that is raised to a higher power, say x squared raised to the power 3. Here what you do is you multiply the powers. So you shall have x to power 2 times 3, which is equals to x to power 6. So now in summary, the key points that you have to note is 1, a to power m times a to power n. This is equals to a to power m plus n. Then a to power m over a to power n. This is equals to a to power m minus n. Then a to power m to power n is equals to a to power m n. Then a to power 0, this is 1. Then a to power 1 over n, this is equals to the nth root of a to power 1. Then if you have a to power m over n, this is the same as the nth root of a to power m. Then if you have a to power negative m, this is the same as 1 over a to power m. Then the square root of a number produces two results. For example, root of 16 is equals to plus or minus 4. So these are the important points to take note of, at least if you're dealing with indices or powers. So that's all for today. Thank you so much for watching. Please do not forget to subscribe to this channel. It's completely free of charge. Thank you, and let's meet in the next video. Bye.